Hi guys. So today we are going to be looking at finding the inverse of a 3 by 3 matrix. Now, if you guys can recall, in previous videos we covered finding the inverse of a 2 by 2 matrix. And the formula is quite similar to this one, where instead of adjoint A, we had a matrix involving the interchange of the leading diagonal and a change of sign of the second diagonal. Now, finding the inverse of a 3 by 3 matrix is just a tad bit different, where we have instead something called the adjoint. Now, exactly what is the adjoint? Take note that ADJ is shortened for adjoint, right? And the adjoint of a matrix A is simply found by transposing the matrix of the cofactors for that particular matrix, right? Now, if you guys watched my video on transposing matrices, you would remember it's just where you rewrite rows as columns. And also, the video just before this one, I think, we went into depth of how to find a matrix of cofactors. So if you're looking at this video and you have never heard the words transpose, you have never heard the words matrix of cofactors, you guys definitely need to go back and look at those videos I have uploaded before looking at this video, because you might find yourself a little lost. Okay, so once you do, welcome back. So we're gonna move forward with this and how we can apply this formula. I'm gonna actually get straight into a question with this because it's super simple. So looking at an example. All right. So let me write in green today. I'm feeling a little bit, All right. So let's just say we have a matrix. By the way, the matrix doesn't always need to be called A. It can be called B. I'm going to call my matrix B. Okay. Let's just say we have a matrix B and it has elements 1, 2, 1, 0, 2, 2. And -1, 1, -1. And it's, just minding its own business. And then suddenly somebody says, hey, we'd like you to find the B inverse. And you're like, okay, no problem. Hey, this isn't a 2 by 2 matrix. It's going to be requiring us to do a bit more work. Now, from the formula, we know that to find B inverse, it's going to be given by 1 over its determinant by the adjoint of B. And to find the adjoint of B, we're going to have to do a bit of work. Now, first up, the determinant of B as well. You guys can review my video on finding determinant of a 3 by 3 matrix. But for this question, I'm simply going to state the answer. You can review my video on finding the determinant of a 3 by 3 matrix. And once you review that video, please be sure to verify that you are getting your answer to be -6. So check. So the determinant of B for this question is -6. And now what we are going to move on to is finding that adjoint. Now, the adjoint, first of all, of B, let me write this properly. The adjoint of B, guys, is simply the matrix of the cofactors transposed, right? So I'll just write a little shortened kind of, personal notation for me, my eyes only. I understand this means the transpose of the matrix of the cofactors. So before we could even transpose a matrix, we need the cofactors. So we have to have some sort of lineup taking place where we find each of those cofactors. And if you guys can recall the video on cofactors, if we were to find that first cofactor that goes in this position, that's the position of first row, first column, it would be equal to, start with your positive sign, and if you eliminate the rows and the columns that that element belongs to, it will be the determinant of the remnants. And the determinant of the remnants is 2 multiplied by -1, subtract 1 multiplied by 2. That gives us -4. And what you're going to do is you're going to find all the cofactors using this process for the entire matrix. Now, you guys can go ahead and work, and I will tell you that eventually, for this question, the matrix of cofactors at the end, when you generate the values from B11 all the way down till the last one, works out to be -4, 3, 2, -2, 0, -2, and finally 2, -3, and 2. Now that's just the matrix of the cofactors. If we go back to our adjacent is given by the transpose of this matrix. So transposing this matrix will give us, remember, transposing means to switch your rows or columns to become rows, or rows to become columns, and vice versa. So we are going to select our first row and change it into a column. So it's written vertically down. We are going to select our second row and write it vertically down, and then our third row and write it vertically down. So once you have successfully transposed your matrix, making sure you have no mistakes whatsoever, then we can go ahead and we can do our last step. That says our inverse is given by, remember the formula is just a very simple one. It's 1 over your determinant multiplied by your adjacent. So it's just a matter of bringing your two answers together. Our determinant was found to be -6, and our matrix was given by this here above. So we will just rewrite that. And of course, if you choose to, you can bring your constant, which is -1/6, into each of these values, such that you will end up getting your inverse of your matrix to be equal to, that's of course if you choose, you would get 4/6, which is 2/3, you would get -1/2, you would get 2/6, which is 1/3, you would get 2/6, which is 1/3 here, you would get 0. You would also get 1/3. You would get -1/3 here. You would get 1/2, and then -1/3. And that's your final answer if you prefer to bring your constant into. For those of you who can't recall how to bring a constant into a matrix, it's just a matter of multiplying that value on the outside by each of the elements inside of your matrix. Okay, guys, so this is how you would find the inverse of a 3x3 matrix using that cofactor method. And of course, you would need to know how to find the determinant of a 3x3 matrix, and you would also need to know how to find the matrix of cofactors and understand what transposing means. So it's not too shabby. It's not too shabby. It's pretty straightforward if you think about it. There's no catch as in integrating. Okay, guys, so if you would like to see some more examples fully worked, please leave a comment down below and I will be sure to do a tutorial session on this topic. Thank you very much for watching. Glad to be with you. All the best and take care. Bye.